We're getting into the 3D reactions and statics. So this might look familiar as a pin connection. The blue part here would represent the pin, and we might have a body associated with it. And in 2D, we would have normal forces acting in both the x and the y direction. And now we're moving to 3D. Okay. So in 3D, if that pin support is sufficiently narrow, it really only acts the same way as the pin connection. It really just exerts a vertical force and a horizontal force. And we'll try to demonstrate, some of the motion that could be acceptable through a very skinny feeling bearing or pin selection here. Okay. So we can translate through that bearing, but it also, if it's thin enough, does not stop any rotation. We really have just an x and a y force if z is along the translational axis here. Okay. The way it's shown here in Onshape is an x-axis, but we have two forces stopping translation. Okay. Quite often in the real world, when you see a situation like this, you do see two bearings used together in conjunction. And when you have those two bearings, you'll end up stopping the rotation. Come on. There we go. We will still have translation, and actually this axle can still rotate as well. So the two bearings used together does end up stopping rotation. Here you see the two bearings acting together, each lifting up on the axle and each holding it into the center. Again, there's no stopping of translation, but ultimately the combination of these forces do cause restriction in rotation. Now, both of these are shown as going upwards, but really they're going to act as a couple. So let's just show that a little differently. Here I've shown forces in opposite directions. Okay? They're not necessarily equal and opposite because we do have the tendency to stop translation as well. But hopefully we give you the sense here that these two bearings acting together will stop the rotation. And this is typically what you'll see in a physical setup. However, sometimes we can replace the effect of two bearings, which stop the rotation, with a single bearing. Occasionally, when we cannot have two bearings to support a rod, you can support it with a single bearing. And a single journal bearing does have to support the rotation on its own. So it kind of acts like two, where the forces really are going to be more localized on the endpoints, but we don't show it that way. Okay? So while it kind of acts like two bearings with forces at either end, and one end's going to hold it down and the other end's going to push it back up, we don't show the forces that way because we're not always given the width of the bearing. When we have a large bearing and it is supporting a rod on its own, that is when we include the reaction moments. So when a bearing holds a rod on its own with no help from another bearing, when it's not used in a pair, it stops the rod from sliding side to side, it stops it from going up and down, but it also stops it from rotating around what this orientation looks like in x-axis. And it also stops it from rotating around, again, an observed z-axis in this location. It does not prevent rotation around y. And for a journal bearing, it does not prevent translation along y. A thrust bearing would be used to stop translation around y. So another hint as to whether you should be using moment reactions or not is count the number of unknowns. If by using those moment reactions gives you more than 6 unknowns, then you're in a situation where you probably really shouldn't be using those moment reactions. Here we have 2 bearings shown together. One is a journal bearing, which does allow translation, and one is a thrust bearing, which does not allow translation. And if we were to include the reaction moments, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 unknown reactions. And for a 3D rigid body equilibrium problem, we can solve a max of 6. So this is not solvable. And so we assume that the moment reactions are negligible given the fact that there are normal forces that can stop that rotation. So the pair of normal forces between the 2 different bearings, that'll stop the rotation better than an internal reaction moment. So with 2 properly lined bearings, 1 journal, 1 thrust, we have 5 unknowns, which means this can still rotate, but typically in those problems there will be another reaction to consider.